Hi everyone, welcome to your second lesson in circles. In this video, we're going to be looking at a lot of the very advanced measurements within a circle. There's a lot of formulas. You're definitely going to need a calculator, and I'm sorry, but it's another long video. There's just so much for us to cover. So stay with me. Come ask me questions. If you need to pause the video and come ask questions, or you could even pause the video and go do a couple IXLs and come back, whatever makes it sink in for you the most. So let's get started. First, we're going to look at arc and angle measures, and you may be thinking that we've already done angle measures. In the first video, we did central angles and inscribed angles. Well, believe it or not, there are more angles. There's angles created by intersecting chords, secants, and tangents. So we're looking at a whole lot more here. So let's take a peek. In our first example, we're looking at when we're looking at an interior intersection where we either have secants or chords that intersect. The thing to make sure you realize is they're not intersecting in the center of the circle. So these are not central angles. They're just kind of randomly positioned around the circle. The postulate says that if two secants or chords intersect inside of a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. Let me write that down. The angle is equal to 1/2 of the sum of the two arcs. Okay, and we are going to have two arcs. So let me show you what we're looking at here. Let's say we're trying to find angle 1. All right, well, we know we have a set of vertical angles. We know that BC and AD are the arcs that go with angle 1 and its vertical angle. So for this postulate to apply, the measure of the angle is equal to 1/2 of the sum of the measure of whatever AD is plus whatever arc BC is. So this pattern would be applied to this circle in this way if we're trying to find angle 1. Now look how it changes if we're trying to find angle 2. All right? Angle 2 has a vertical angle, and it has two intercepted arcs that go with those angles. Highlighted them in orange. So angle 2, if we're following the postulate, says that the angle is equal to 1/2 of the sum of the arcs. Well, this time the arcs are AB and CD. So we're using two totally separate arcs because we're finding a different angle. Let's see what one of these examples could look like. The measure of angle AED is what we're looking for. Okay, well, AED, this orange angle that I've outlined, is vertical, and the two arcs that are created by this vertical pair are arc AD and arc BC. And we're starting out super basic here. These arcs have been given to us, and that's going to keep it simple. So if I'm following this pattern, the angle is equal to 1/2 of the sum of the two arcs. Then I'd set up like this. The angle is what we're looking for. So we're looking for X in the angle position. And that is equal to half of arc number 1, 45 degrees, plus arc number 2, 109 degrees. Okay, well, I'm just going to follow the order of operations here. I need to add together 45 and 109 first. That equals 154. And now I need to take that value and multiply it by half, or just divide by 2. Multiplying by half and dividing by 2 are the same thing. So my angle equals 77 degrees. This is a brand new postulate here. The angle is equal to half of the sum of the arcs. All right, let's try a new example. We're looking for angle STR. STR, put an X there. Okay, it also has a vertical angle in our picture, of course. So it creates two arcs. It creates arcs SR and arc PQ. So let's look at our formula. Angle is equal to half of the sum of two arcs. Angle is equal to half the sum of two arcs. I'm looking for the angle, and the two arcs are 186 degrees and 112 degrees. Follow your order of operations. Do parentheses first. 186 plus 112 is 298. So I am looking for half of 298. You can multiply 1/2 and 298, or you can take 298 and divide it by 2. 298 divided by 2 is 149 degrees. So this angle measure, it is an obtuse angle that matches our picture. It's 149 degrees. All right, well, what if, let's just say, this postulate says that, that they have to intersect inside the circle. So what if we have a situation where the secant or chord and a tangent intersect at that point of tangency? They intersect on the circle instead. But we're actually catching a break. Okay, because what we have created here is just like an inscribed angle. It says the measure of each angle formed is equal to half the measure of the intercepted arc. So this is just like an inscribed angle. The angle is equal to half the arc. The angle is equal to half the arc, just like with the inscribed angle. Okay, so let's say I want to find angle 1. Angle 1 creates the arc from A to B. So angle 1 would be equal to 1/2 whatever the measured arc A to B is. Angle 2 is very different. Angle 2 creates arc ACB. It creates a major arc. So the angle is equal to half of its arc, and its arc is ACB. Bigger angle, bigger arc. Let's see how these work. Write in my formula, angle is equal to half of the arc. Okay, I am looking for angle, angle DEG. So the arc that goes along with DEG starts at E, goes all the way around to H, and finishes up at G. It's a 308-degree arc. I'm looking for the angle, so I put X in the angle position, and the arc is given to me at 308 degrees. There's really no algebra to do here. X is all by itself. I just need to know what half of 308 is. 1/2 of 308 is 154 degrees. So my angle is a very wide obtuse angle, and it is half the measure of its arc. Okay, in example 8, we are looking for angle DBC. DBC. DBC creates arc from D to B. Okay, in order to find the angle, we have to know how much the arc is. And here, we don't know how much the arc is yet. There's some other information in this picture that might help us, but as is, it's not given. What is given is this big 192-degree major arc on the top part of the circle. If a circle adds up to 360 degrees total and the major arc is 192 degrees, Whatever's left after subtracting will be the minor arc. And I get 168 degrees when I subtract those. So this arc out here is 168 degrees, and that's what I can use to plug into my problem. The angle is equal to 1/2 of the arc, and our arc is 168 degrees. So I need to multiply 1/2 times 168 degrees. Now I'm getting an 84-degree angle. Why don't you give the next one a try? I'm going to pause the video while you have a moment to look. Is there anything tricking you up on this one? Look at this question. They've switched it up on us. Now we're asked to find an arc. I've highlighted arc XY, and I'm stopped here because I feel like students might get stumped. We need to know what the angle is so that we can plug it in to figure out what the arc is. Well, the angle I've been given is a 151-degree angle. However, the angle that goes with my arc is very acute. So these two angles lined up together are a linear pair. And a linear pair adds up to a total of 180 degrees. So if I take my 180 degrees and subtract off the big obtuse angle, what's left is going to be my acute angle. 180 degrees, take away 151 degrees, leaves me with just 29 for this acute angle. And that's what I need to plug into my formula here. It's a 29-degree angle. Now, if you weren't able to get that far, take a moment and solve for x.